All right. It is now 6 Eastern, 5 Central, and we are ready to start this second. Well, I don't know if it's actually the second, but Microbiology Roundtable on Tuesday, June 7th with Dr. Roy Vore. And this, again, is part of a series open to all members of the Floatation Tank Association, but also the public. And for anybody that's joining us live right now on Zoom, feel free to drop any messages or comments or questions in the chat. There will be an opportunity after Dr. Vore has a chance to give his presentation to answer any questions that you might have, which I'm sure there'll probably be a bunch. And you can do the same on Facebook too. But if you are listening on the collective, we really encourage you to join us here in Zoom, because it's always fun, to have you here, and you can ask your question actually here live with us and participate. But with that said, Dr. Vore, take it away.
Good evening, good afternoon, all. It's like, let me pull up some slides here and okay, John, can you see that?
Yep, and we can see it on all streams, so we're good to go.
All right, so this is, part of the microbiology discussion coming out of the Sanitation and Regulations Committee of the FTA. And as usual, if you've ever heard one of my talks, you're never going to figure out where it's going to go next. And I promise you, I will continue that practice tonight. So one of the really nice things that I like about working with this group is the diverse skills that we have and the experiences we have. And in my 40 some years of working, I find that the more broad-based education you are, the more successful you are in business. So we're going to continue that. So we're going to start off brain teasers tonight. I've got a series of 5 questions that I'm going to ask you. Tonight, it's like 2 in biology, 2 in earth science, and 1 in food science. And so I'll give you about 10 seconds to think of the answer. And, it's like, as usual, you're going to get a very special reward for answering all 5 questions. Okay, everybody ready? Okay, here we're going to go. First question's in biology. What animal looks like a cross between a duck and a beaver? Now, this is the easiest question in the entire series. So you should know.
Platypus?
Duckbill platypus. Yes, John gets 1 point. Yeah. Okay. Here is the more difficult question. What is an ichneumon? I can hear your little gears turning right now.
It's a wasp.
It is a wasp, but what kind of wasp is it, John? Partial credit only. It is a parasitic wasp. And the reason this comes up is, you see that one there on the lower left in there? That long thing is an ovipositor. It is not a stinger. It drills into trees and it lays eggs inside of an insect, and the eggs hatch and eat the insect from the outside. You ever seen the movie Alien? This is where it comes from. And there's different kinds of ichneumon. So these are very beneficial wasps. But that concept in Alien where the egg crawls in you and hatches, and it's like, come on. Nature's been doing this for, I don't know, a couple 100 million years. That plot in Hollywood was not new. All right. And by the way, these are the insects that we're going to use in my own neighborhood to control these beetles, which are destroying our trees. So you can buy these things and sprinkle them around the yard and do a natural insect control. Okay, earth science. What is the tallest mountain on Earth?
Mount Vesuvius.
It is not Mount Vesuvius.
The only mountain I could think of with a long name.
It is not Mount Everest either. It is actually Mauna Loa volcano in Hawaii. Now, it only rises 13,600 feet above the water, but it actually rises from the ocean floor. So it's 33,500 feet from the ocean floor to the top. That is 4,468 feet taller than Mount Everest. So this is an example of if you look below the obvious, sometimes the answer is different. What percentage of water on Earth is fresh by definition? Now, we all deal with water every day. We start with water, we drink water. What percentage of water is fresh by definition? Anybody want to hazard a guess at all?
%40.
What was that, David?
40%.
Well, we're going to give you 1 point for trying, but you're a little bit off. It's 2.5% because the oceans.
A little more than a little.
Yeah, a little bit. We're going to give you credit, though, for trying because that's more than John did, and it was like, okay, All right. And if you've all been reading the news at all, you know that, the water behind Hoover Dam and Lake Mead, the reservoir is only at about 40% capacity right now. Lake Mead is down 175 feet. The last time it was full was 1983. If you've ever been out in the Southwest, you know that there's a serious water shortage out there. And the drought in the Southwest is the most serious drought in 1,200 years. Okay, last question. How does artificial sweetener work? And this was really good because somebody brought up that we use, I think, David, was that you, that said one study is you measure the amount of artificial sweetener in a swimming pool and you can correlate to how many people were swimming in it because people release a certain amount of urine when they're swimming because your muscles relax. So how does artificial sweetener work? Why does it taste sweet? And the follow-up on that is, why is it so controversial? And it's not because it causes cancer. It actually stimulates the same taste buds that sugar does. And so it fools the body into thinking that you have sucrose, which is table sugar. But what makes it controversial is it can be utilized by the bacteria in our guts. And as a physiologist, this is the way we used to identify bacteria before DNA. You use the alcohol sugars, the sorbitols, the mannitols, the xylitols, and some bugs could ferment it and some couldn't. And so we've known for well over 100 years that these types of compounds are used by bacteria, but not by humans. And so the controversy around artificial sweeteners is it impacting the natural flora of our guts? And I threw this in here because there's a lot of us in the float sector that are pretty health conscious. So if you're using artificial sweeteners, you might want to be aware that there's a lot of current studies saying this is changing human metabolism by changing the flora of our guts. Okay, all right. So if you got all 5 right, I want you to take one hand, hold it in front of your face, and take your other hand and hold it in front of your face and bring them together in a clapping motion. All right, I promised you a prize, and the prize was you did good. I didn't say the prize was worth anything at all. But anyway, okay, we've got 3 questions we want to start. And what do we call the liquid in float tanks? And this is a question that has popped up repeatedly in the last 6 months. What are we agreeing to call that liquid? Is it water? Is it something else? And so this is one thing I think the FTA can help standardize is the jargon. So let's start there with that easy one. What processes are involved in float tank treatment? And what chemicals can you readily utilize for disinfection? What chemicals and what processes? So it's naming, processes, and how do we actually disinfect? Okay, let's start off with that first question. What do we call the liquid in float tanks? All right, we all know the specific gravity is 1.24 to 1.3. Tap water's got a specific gravity of 1. Now, scientifically, that says there's a pretty big difference between the two. And we know that if you're trying to use a swimming pool test kit, which is designed for water, it doesn't work in float tanks. And so if something doesn't work in water in a swimming pool, if something works in a swimming pool but doesn't work here, is that scientific evidence that float liquid should not be considered water? Now, here's a couple of other thoughts. All right, there are other things that have something in it that we don't call water. For instance, coffee. Coffee is more than 99% water. When you're drinking a cup of coffee, what do you say? Hey, I'm drinking a brown water. No, you call it coffee because it contains something that modifies the water. Milk, depending on whether it's 2% or 4% or whole milk or fresh out of the cow, it's 94 to 98% water. But we don't call it white water. We call it milk. Beer. Some of us know a little bit about beer. The average is about 95% water by weight. So do we call it slightly colored water with alcohol, or do we call it beer? Now, so float liquid is about 70% water by weight. Maybe 74%, depending on what the specific gravity is. What do we call it? What is the standard terminology we want to be referring to it? So this is a question that I want you to think about. Now, generally speaking, the term that I'm hearing used is float solution. So is that the term that you are using? Are you calling it float water? So it's like, if we're seeing any information, John, are we getting any feedback on that?
Not that I can see right now, but I will give my feedback and say that what I know, or at least what I call it, is a solution. And it looks like Amanda also calls it solution as well.
Yeah, so this is a key terminology that we want to standardize on and then educate the Department of Health so that it is not being confused with swimming pool water. And so this is a conversation that I would like to continue to have over the next year or two. Now, in the FTA standard, we call it float solution. And so it's like, as we continue forward on this, this is where we begin to harmonize our best practices and our terminology. Okay, that's the thought for the moment on that one. But let's talk about processes that we use in treating water. And you may not have thought about this, but there are 3 separate processes that we use between floats. We have filtration, Often, but not necessarily always, we have oxidation and we have disinfection. And these are three separate processes. They have three separate distinct objectives, and we need to be treating them as different processes. All right, filtration is a mechanical process. We remove solids. Some of them are very small. It depends upon the size of the filter pores that you're using, whether you're using a cartridge filter, whether you're using a 5-micron bag filter or a 1-micron bag filter. So we're removing solids from the float solution or float liquid, but we are not changing the chemistry of the material of the solution itself. Now, there are limitations to the filtration. It's what is the pore size that you are using. If you want to removing bacteria, then you've got to be using something like a 0.1 or a 0.2 micron, and you're going to have something like a 30-horse motor to push that through. And so you're not removing bacteria, but if you're using 1 micron, you could be removing Cryptosporidium. So it's a selection process. It's a matter of energy efficiency, flow rate as to how you do that. All right, then there's a question of how many times do you pass the liquid through the filter? In many of you've got the two basic designs where you drain 100% of the water out, you put it in a holding tank, and it goes through the filter one time and goes back into the tank. And then you've got the more traditional approach, probably most people have that, where it cycles through the filtration 3 or 4 times between users. And the more time you put between, the more cycles that you put on there, the more efficient it gets. If you get 90% of material in one cycle, then you get 90% of what's left in the second cycle and 90% of what's left in the third cycle, depending on the pore size. But then there's also the mixing rate. If you are doing a complete drain, you have complete filtration. But if you've taken the CPO course, you know that if you are not doing a complete drain, you do not have efficient mixing in there. To get efficient mixing in a conventional design, you must run it through the filter a minimum of 3 times, and that'll give you about 94 to 97% efficiency. So the number of times that you filter is a critical factor. And we go into this very much in detail in the CPO course. All right. One point to think about is the cheapest treatment that you can do is your filtration. Yes, it costs you electricity, but if you look at the amount of electricity and your bill from running that pump, it is cheap. And from a manpower viewpoint, it is very cheap. You turn the switch on and you're done. So you don't have to spend a lot of time dealing with all the chemistry and measuring all that. So it's a very cheap process, and it can be improved depending upon your filtration. All right, now let's talk about filtration a little bit. All right, I think most of you know that I'm a pool boy. So I run swimming pools for a living, and I do the float tanks for fun. All right, now on the left here, this is a typical in-ground pool. This is one of my pools. This is the 3rd year I've run this pool. It's about 35 minutes south of where I'm sitting right now. And you can see the winter cover on it. And this cover is a little bit loose because we've already started taking it off. And you can see this was on May 5. And when the cover is very tight, it's designed that you can walk across the cover and not fall in. So it's called a winter safety cover, so that you don't fall into freezing water and drown in the middle of the winter. All right, so on May the 5th, my daughter and I show up, and then we pull the cover back, and you've got the picture on the right. And you can see the cover down there on the far end down there. This is what the water looks like in 90% of the swimming pools in the spring after it's been closed all winter long. So how am I going to treat this? Well, I'm going to give you an example of filtration, and I'm going to show you what you can do with a green swamp. And the visibility in that water on the right, we could see about 3 inches into it, 3 inches. The deep end of this pool is a little over 8 feet. So we're going to start out with this swamp on May the 5th. And then on May the 6th, I came back and I started adding a flocculant to it called aluminum sulfate, or shortened it to alum. And you can see it starting to scum over on the top, on the picture on the left. And that's what we want to do. We want to coagulate all the stuff, and then we settle it to the bottom. And look over there on the right, you can see the vacuum hose laying into it, and you can actually see the bottom of the pool on the right. That water is 3 feet deep, and you can see the bottom of the pool. All we did was coagulate the material and settle it to the bottom, and we're beginning to be able to see the shallow end. All right, so let's look at a close-up on the same day, and the hose is in about the same position in here. You can see the bottom of the pool. So I've begun to vacuum out. And on the right, that's what it looked like after it had all settled. And you can see all that green stuff, that was all algae and dirt that had gone through this mesh cover. And so it had settled to the bottom. And what I'm doing is I'm just vacuuming this out and then filtering the water. Think about it. We start with that on the right. We do a little bit of treatment, and we get what we see on the left. All we did was remove the solids. We go from a green swamp to the beginning of a blue pool. No disinfection, no oxidation, just filtration and solids removal. On the right, I've begun to add chlorine. If I would have used chlorine alone, the cost to me at wholesale of using the chlorine would have been around $125. I used about $4 worth of coagulant and filtration and solids removal. This is the power of filtration that you can use in your float tank. Yes, it is a dramatic example, but it illustrates just how effective filtration can be. All right, so it's hard to relate to a pool, perhaps. So let's look at cartridge filters, and many of you have cartridge filters. Okay, on the left, that's what a new cartridge looks like. You're used to that. On the right, those cartridges have run 1 year. That is the material that we took out of a swimming pool in 1 year. The cartridges on the left weigh about 2 pounds each. The cartridges on the right have gained between 10 and 15 pounds of dirt, debris, hair, leaves, and anything you can throw into a swimming pool. The water looked absolutely fabulous the entire year in the swimming pool. But by simply filtering, we removed pounds of material from a 15,000 gallon swimming pool about 25 miles north of where I'm sitting right now. Water looked great. Filter, it was cheap. It was cheaper than all the chlorine I was using. All right. And by the way, the cartridges on the right can be hosed off. used a spray-on filter cleaner after it's hosed, and reused. So the filters are not destroyed, they can still be reused. So many people are used to recycling filters. This is the power of filtration. All right. The next thing we want to talk about, and this is something that we do not talk about very much in float tanks, is oxidation. Filtration, we remove solids, but in oxidation, our idea is that we change the physical structure of a small particle or something that is a little bit larger, and we either remove it by filtration or we volatilize it right into the headspace. All right, and if you've ever been around a swimming pool, you can smell some of the stuff coming off swimming pool, so you know what volatilization is. But there are two kinds of oxidizers that we can use. We can use selective, and they have a very limited range of activity that they would destroy things. And then there's non-selective, and they will whack just about any kind of compound that they run into. And so how we select our oxidizers depends upon how efficient they're going to be. All right, what kind of oxidizers are they? All right, you're all familiar with chlorine. Some people are using it, some people are not. You've got a liquid. It adds sodium chloride, but it doesn't have very many solids in it. Cal hypo, I would hope no one is using calcium hypochlorite in there because it will cloud your water. It's a granular material, but if you were using calcium hypochlorite, I'd suggest you get a hold of me and we're going to talk about this. You could use sodium dichlor. It will not cloud the water, but the health department may not like it. And there are a few places, like in Florida, they like to have chlorine feeders on there. Some places in Florida are using liquid chlorine feeders in there. And so which chlorine you use has advantages and disadvantages if you are required to use chlorine. All right, a bunch of people are using hydrogen peroxide. I've got a lot of experience on hydrogen peroxide in swimming pools. It's totally incompatible with chlorine. So if you're using chlorine, do not be using hydrogen peroxide because they're mutually destructive of each other. And if you are using hydrogen peroxide, don't spill it on cardboard because it will dry and it will get to about 80% concentrated peroxide, and that cardboard will catch on fire. Have you been trained on that one? So hydrogen peroxide, there's a couple of different varieties. I know a lot of people are using 37% or 35%, and that's the commercial stuff. But you can buy liquid peroxide at a swimming pool store that sells a product either called Soft Swim or Baquicil at 27.5%. It is not nearly as hazardous. So there is an option rather than buying big drums of 35%. It's a little bit safer to go down to the 27.5% from a swimming pool store. You can check and see, do you carry peroxide in the store? And they'll tell you right off the bat. All right, a lot of people are using ozone. Requires a generator. There's a couple of different varieties of generators in there. So ozone is a very good oxidizer. Advanced oxidation processes. I know a number of people are using the small Dell systems in there, the AOP systems on there. It is a combination of UV and ozone. And there's another product that we use in swimming pools that might be very suitable. I've never seen it used in float tanks, but it is a very potent oxidizer. So this is something I want to make you aware of, but I'd be cautious when the first time you try it. And if you want to try it, you can get a hold of me and I can walk you through how to do this. It's called non-chlorine shock or non-chlorine shock oxidizer. It's available in a number of brands. I've got a lot of experience with that. I've worked at DuPont for a number of years, and I was one of the people that supported that. So it's very potent in swimming pools, and I carry it on my truck all the time. But if you notice, I didn't say anything about UV. A lot of people have UV systems, but by definition, the chemists will say that the UV systems are non-oxidizing. They may break down materials, but they are not considered an oxidizing product by the definition of chemistry. So UV is an option, but it's more of a disinfectant than it is an oxidizer. Okay, so how do you compare these things? Well, chlorine is a very potent oxidizer. It's non-selective. It hits everything. And if you spill a little bit on your fingertips, you will smell it on your fingertips, and that's if you chlorinated the proteins. And what you're really smelling is the chlorinated proteins. Hydrogen peroxide is a very good oxidizer, but it's very selective in what it hits. So it will not hit all the compounds, but it's very easy to use and does not cloud the water. Ozone is very high oxidizing. It is somewhat selective, but less selective than hydrogen peroxide. So it's somewhere between hydrogen peroxide and chlorine as to what it hits. And probably the most potent oxidizer that we could use in float tanks is an AOP system, an advanced oxidation products, or in advanced oxidation processes. It has very high oxidizing potential, and it's very potent. AOP systems were first used about 30 years ago in wastewater treatment. And so the water coming out of these large sewage treatment plants smelled really bad. And they figured out how to do these AOP systems in there. And basically coming out of a very large sewage treatment plant, they used AOP, and the water was probably much cleaner than was in the river they were putting the water into. So AOP systems, if they're running properly, are really, really powerful systems. In monopersulfate, it has very high oxidation potential, but it's a little bit selective. And so these are options that are available to you. And I think one of the objectives here of the FTA over the next few years is develop more user guidelines on how all of these would be used and the dose rates that we would be using in there. And part of that information, we're going to recruit from all of you listening, what rates are you using? And the idea is we will develop a series of best practices so that we can all share effectively back with everybody. So everybody knows some of the ins and outs, because everybody's learned a few lessons that we would like to share with everybody to make every system the most efficient that we possibly can. All right, now you thought we were going to talk about microbiology. So now, after we've got filtration, after we've got oxidation, now we finally get down to talk about disinfection. It's the third of the three processes we want to talk about. And so the idea of disinfection is we're reducing the number of living microbes or viruses to an acceptable number. Second bullet point, we do not make float solution sterile. We manage the amount of microbes present. We do risk reduction. So we reduce the risk of getting sick to an acceptable level. There is always a risk. The risk might be 1 in 100 million, but 1 in 100 million is still a risk. I mean, compare that to driving drunk the wrong way down an interstate at 3 o'clock in the morning. We are going to reduce the risk by wearing our seatbelt, driving within the speed limit the correct way with our headlights on, going down the interstate. So we reduce the risk. We do not eliminate the risk. And so the first thing I want you to say is, like, never, ever, ever try to tell somebody that there are no germs or bacteria or something in a float solution, because there are a few. They just happen to be very, very limited in the number. That makes the risk incredibly small. Okay, so let's talk about what kind of disinfection could you use. All right, guess what? It's the same kind of chlorine that we had before. You got liquid bleach, You got cal hypo, you got sodium dichlor, you got trichlor, the tablets. It's the same benefits because these are oxidizing disinfectants. So they oxidize material, and any chlorine that's left is then available to kill. So you have to oxidize the organics, establish a residual, and then kill. All right, more on that in a minute. All right, you got UV. UV wasn't an oxidizer, but here it is. It's a UV lamp. We've all seen these things. Ozone is kind of like chlorine. It oxidizes, and then residual ozone disinfects. Again, we see AOP systems, same discussion before. And here we also see filtration. It depends upon what you're trying to remove and whether or not you have the right pore size. We can't filter effectively bacteria, but we can filter things like Giardia and Cryptosporidium, which the health departments are really nuts on. And so we could put in a system like a 1 micron bag filter and say the health department says, hey, we have filtered 99% out, and that is more efficient than the CDC's Model Aquatic Health Code says we need to be. So we can use filtration for certain organisms. All right, so how do we compare these four? Oh, and a note on hydrogen peroxide. All right, it is not a disinfectant. Do not try to say that you are disinfecting the water with hydrogen peroxide, because I guarantee you at the concentrations that you are using, it is not a disinfectant. I have studied this for a decade or so when I was with a pool company between 91 and 2005. And I've tested it many, many times at the concentrations you're using. It will not kill bacteria. It will not inactivate viruses. It is an oxidizer, period. Okay, so how do we compare these? We've got chlorine, we've got UV, ozone, AOP filtration. Chlorine's a very broad spectrum, kills everything. Is it effective in float tanks? I don't know. I'm a PhD microbiologist that spent the last 31 years working in recreational water. I have run as many disinfection studies on swimming pool water as probably anybody alive today. And I do not know whether it will work in the specific gravity with the amount of magnesium sulfate that we've got. I don't know. It's never been tested. Until it's tested, until there's some data, I'm going to tell you I don't know. And by the way, you can call up any manufacturer, Biolab, Salinas, Occidental Chemical, Allchem, anybody that makes swimming pool chlorine and say, will it work in a float tank? And they're going to give you the exact same answer. Then they're going to say, by the way, it's not US EPA registered. And so they're never going to give you an answer. So we don't know whether it works, but it's a great oxidizer. But we also know you cannot effectively measure it with available technology. So we don't know how much is in there. All right, UV, very good, very broad. It's effective in float tanks. And the manufacturers will say, yep, this is a good system. Ozone, same category as UV. AOP, very broad, very effective in float tanks. Filtration depends upon the pore size. So yes, there are options when you are either picking new tanks or picking options to rebuild the current tank. And you also need to know what the health department is going to tell you, because if the health department tells you you have to use chlorine, if you want an operating permit without fighting them in court, you might have to use chlorine. And so I'm talking the science here. The health department may be talking their own rules. They are probably not nearly as knowledgeable as you are on how to run your own float tank. So this is an argument that we will be continuing to have with health departments until we get more data on here. All right, so now you know about filtration. Now you know about oxidation. Now you know about disinfection. I've got one more slide to share, and then we're going to open this up, and we're going to see where we're going to go from the conversation from there. And that is, you probably thought I was going to talk about the microbiology project. Well, I am not going to talk about it tonight. The reason I'm not going to talk about it, because I'm going to be presenting a poster on this at FloatCon. All right, you're on here. Have you bought your tickets to the Float conference yet? All right. If you want to hear more about the microbiology project that we're using, get a plane ticket, get up to Portland, Maine, have a good time with us, because some of us know that we're going to have one heck of a party Saturday night. And in the meantime, we will be running a special poster session. So we're trying to bring in some science. And so I'm going to have some results there. We've got a number of centers that have submitted data. Now, if you've got more microbiology data, you can get a hold of me. I'm still accepting data. We're doing more data, and we're starting to get some interesting results. So I'll share the preliminary results at Float Conference coming up here in Portland, Maine. And we'll discuss it then. And we'll probably arrange that when the Float conference is on, there will be some adult beverages. So I'm sure the conversation will, roll off our tongues in here. And so it's coming along very well. I have seen no surprises, and I have absolutely no doubt that we're headed in the right direction. And we're beginning to develop a significant database that will make an interesting peer-reviewed publication. That probably will not be out in journal format until about a year from now. So we're still accepting data. Get a hold of me, get a hold of the FTA, send a note into info@the FTA, and everybody on the board sees those emails, and I usually respond pretty quick in there. All right, that's all I've got for the night, people. And so now, what are your thoughts? Oh, I see Jocelyn just conference in there. It's like, yep, if you see the link in here, Jocelyn's got the link in here. And it's like, buy your tickets now.
Absolutely. And thank you so much again for presenting, Roy. I just wanted to, because we'll open up the questions. Anybody have a question, you can drop them in the chat. I'll make sure to get that over from Facebook, but also here in Zoom. Or just jump on, Zoom and say whatever you'd like. We'd like the conversation to roll. But I wanted to mention one thing about hydrogen peroxide. It's something that I use. I also use AOP, and I believe in these technologies. But it's so true, and I'm one to admit I make mistakes. And we did actually clean up a hydrogen peroxide 35% spill with a towel, and put the towel in a laundry basket. Okay. And the laundry basket actually started smoldering.
Yep.
My float guy called the fire department. They came. We had double door back open. We were airing out the back room, and they brought the laundry basket outside. They rinsed it down. And then, of course, we got the scolding of a lifetime. Oh. Thankfully, they never fined us or sent us a bill. I was expecting it. I said, yeah, if I owe you guys some money, whatever. But this is a lesson that we've learned. So for folks out there that use hydrogen peroxide, I know it goes without saying, and you can call me a dummy because I kind of am, I'm learning. But yeah, it does start a fire, and be careful. So I just wanted to point that out. Anybody else have anything? Feel free to join the conversation.
And while we're waiting for a question to come in, it's like the question, if you're a veteran on handling hydrogen peroxide, you've had white fingers at least once in your life, because it will bleach the top skin right off. Your finger will go the color of my shirt, which is just like, white. And that happens so quick, you can't even feel it happening on there, particularly on 35%.
Yeah,
so,
without a doubt.
And with hydrogen peroxide, some sort of eye protection is pretty essential on there, because it's like that stuff will make you go blind. So your fingers, if you get white fingers on hydrogen peroxide, we've all probably handled it. You've handled it. The skin peels off in a few hours, and you're fine on there. But by the time your fingers are tingling, your fingers are already white. I mean, it's that quick.
So I actually, and while we're waiting for other questions too, but I posted a video on the collective a while back, and I got a lot of criticism because I wasn't wearing gloves or glasses. I probably should have, but I had, that stereotypical, the solution in the float tank is like that brown, almost like irony kind of color. And the science experiment is, and of course I used the chlorine bleached the water, and I think it's doing something. It turns that color, but then you take like 500 milliliters of the 35%, you pour it in, and it's like magic, like OxyClean. It just instantly clears everything up. That's a neat trick, but we researched it and we realized like when chlorine and hydrogen peroxide come together, it can create some pretty deadly forces. Can you elaborate a little bit on that?
I'm not sure exactly what the end-up product on that is, but hydrogen peroxide, the way you rapidly eliminate free chlorine from a swimming pool, you pour in a bunch of hydrogen peroxide, and the reaction is instantaneous. And then you overdose it a little bit, and you cannot get chlorine back in that system at all. You have to dose the holy heck out of it to get any chlorine back in there. So they are mutually destructive in what they do. And I don't remember exactly what chemistry they release on there, but so if you are using chlorine, do not be dosing your pool with your float tank with hydrogen peroxide, because you're just wasting your money. Use one or the other. Do not ever mix them together.
So Mark Anderson has a question on Facebook. He says, when you speak of chlorine, does this apply the same for bromine? Because you didn't really bring up bromine.
I did not bring up bromine because bromine is the least favorite disinfectant that I know of, and I know of hundreds of them. I would strongly encourage anyone using bromine to get off of it as soon as possible. If you talk to any dermatologist, the sensitivity level to bromine reactions is maybe 100 times stronger than it is to chlorine. So people get rashes from bromine, and to use bromine effectively, you have to chlorine shock it repeatedly, and the bromide builds up. The more bromine you put in there, you build up bromide salt. And then you have to add chlorine to convert the bromide back to hypobromous acid to be effective. Most manufacturers are moving away from bromine production for swimming pools. It used to be about 5% of the swimming pools in the United States. Now it's probably less than 1%. The negative health information about brominated products is very, very, very negative. So I would encourage anyone currently on bromine to get the hell off of it by midnight tonight.
Well, that settles that. I'll just add to that a little bit though, and maybe I'm completely wrong, but I remember reading, I think I read that somebody said that their health department in their county required the use of bromine. Does that sound like an accurate statement, or is that just like?
I think there's probably some health departments in the state of Florida that are actively saying that, and that comes back from a lack of education on many of our public health officials. Part of the advantage that I've got is I've been inside the chemical industry since '91. And I've supported chlorine and bromine and other products through the re-registration process at both the US EPA, Health Canada, and even some European health agencies. So I've seen many, many studies on health impacts that probably most people on here have never even heard of. If the health department's telling you to do it, you probably have to do it to maintain the operation, but put in as little as you possibly can and request they consider an option for that.
Absolutely. And for anybody out there too, that, and we encourage anybody to contact the Floatation Tank Association. If you have any questions, you're looking to open a float center, and you have any challenges with your health department, please reach out to us. But, one of the services that we really like to help with, is helping, navigate the unknown waters of your health department in whatever county you're working with. And the last thing you want to do is invest a ton of money, find investors, and get your float center operational to then find out your health department comes along and shuts you down. The first thing you should do is figure out what the health department requires, and then pick the location and then start operations. And I know that, people have reached out to us and we've been able to provide them assistance. So feel free to email the Floatation Tech Association at info@floatation.org. And even better yet, join the FTA and you'll have inside information in, that progress that we're working on at the FTA. And also anybody that isn't planning on going to the conference, you have to go, because it's a necessary thing to be part of the community that is the hive mind that we're really working at together. Because, and I think Roy, as well, when we get a couple beverages in us, that's when the real science and information comes out.
All right. For anybody who was watching, I was like, yes, I just popped a top on there. It is a generic Dr. Pepper from Kroger. It's a Dr. K diet. And yes, it has artificial sweetener in it, but it also has more cherry flavor in it than Dr. Pepper. So it's kind of like the cherry vanilla Dr. Peppers that you get. So it's like, it is not a beer yet. Oh yeah, I see Jocelyn on there. Yeah, uh-huh. Yeah,
Roy.
That's it, Jocelyn. You owe me a beer now. Mm-hmm. Mm-hmm.
So I was just speaking to some of my colleagues today in the Outreach and Education Committee. I know that the Float Conference has another webinar coming up too. That should be in the next few weeks. If Jocelyn, you'd like to talk about it, you're welcome to. But I'm very excited to join that one as well. And as a reminder to anyone out there, next month in July, we plan on doing a public open forum, like kind of debate about, whether or not you replace your float tank solution. And I think it's going to be interesting, because I know there's a lot of people out there that are very vocal about this, that talk about, I replace it once a year religiously. Other people who are like, I don't think I need to replace it. And I know it's, you might not want to come out and admit it, but like the truth is that let's have a discussion about it. We'll see if Roy's available. I know a couple others that'll be there as well, but that should be a fun time and very informational. And Jocelyn just mentioned we're working on schedules for webinars, but they're going to have one each month. Feel free to join. I know that they're very informational, and we here at the Floatation Tank Association definitely want to help promote those as well. But either way, definitely need to see everybody at the conference. It's going to be one heck of a party in Portland, Maine. So
yeah, let me change hats here for just a second. It's like, because some of you know that I sit on board of directors for both the FTA and the Float Conference. So since Jocelyn's being so quiet on the phone, I will say there is an option. We all know travel's expensive. I just bought a ticket to go to the National Environmental Health Association in Spokane the end of this month. And it's probably the most expensive plane ticket that I've purchased in 20 years. So travel cost is up on here. But if in person is always so much better to go to FloatCon, but there is an option. If you are restricted, you can get a virtual ticket. We have that option in here. It's not as beneficial to you, but it still keeps you involved in the industry, and there will be advantages to you. So if you can stay in touch with that. That's an option. Keep that in mind. Of course, you won't be able to go to the Saturday night party, because we're not going to be streaming it. But
maybe we'll try to find a way to stream it. I don't know. I'll stream it myself then. Fine. One question though, you said you're going to have a poster. That sounds really cool. Like, is that something that it might be created where we can get one and like hang it like in our float centers, maybe.
Oh.
Maybe a digital file.
Jocelyn just added, there's been talk of strapping a GoPro to Ashcon's head for the party Saturday night. I've got a GoPro. I think we should do that.
It's a funny idea. I love it.
With Ashcon's head? No, let's not do that, Jocelyn. We would like to not go to jail that night. Anyway, so yes, the poster will be the preliminary results of the FTA micro project. So we'll be able to share those results after it. And it's a standard practice. We'll have reprints available on the FTA website.
Excellent. Well, fantastic. Well, very excited to see that. Unless there's anything else, anybody else have any other final questions? I want to thank everybody for joining us today, June 7th, for the Educational Microbiology Talk with Dr. Roy Vore. And be sure to join us in the future. But other than that, thank you all and have a wonderful evening.